Hello, this is Mrs. Scarple, and in this video I'm going to go over how we can write recursive and explicit equations with situations that involve percentages. In class we had the example of prairie dogs on a reserve, and they were selling off some of the reserve land as humans wanted more of the land around the reserve. And what they found was during the time before they put a halt to the sale of the land, there was a decline at a rate of 20% per year in the prairie dog population. When the reserve began, they actually had about 600 prairie dogs on the reserve. So a couple of things we need to think about here. When we write our equations to model the population, we're looking at how many are left over time. You need to think about that we start with 100%. But then if we have a decline of 20%, that means we need to take the 100, subtract the 20, and we are left with 80%. And it's that 80% that we want to use in our equations. We want to know how much is remaining. So for the recursive, remember we want to use that next equals previous, and because it's a percent, it's going to be times. So when we have these percent changes, we're going to have geometric sequences, so we're going to multiply. So in this particular situation, my recursive is going to begin f of n equals f of n minus 1 times my percent as a decimal. So 80% as a decimal is 0.8. I also need to say where that population started, and typically whenever you're talking about a population, whether it be the number of bacteria, people in a city, prairie dogs, we start with f of 0. And in this case it's f of 0 equals 600. So make sure when you're writing the recursive you also include where you are starting, in addition to writing what is happening over and over and over again. For the explicit, we're going to have f of x equals the amount we started with. So that's 600 times our common ratio, or what we like to call the multiplier, which in this case is 0.8. And because it's geometric, that means the explicit will have an exponent. And in this case, the exponent is x, because we are starting at f of 0. Remember, when you start at f of 1, this exponent would become x minus 1. If we were to start with something like f of 2, this exponent would be x minus 2. So this is an example of one where we have some decline. Now let's look at one that has some growth. We have Penelope investing $4,000 in an account that would earn 5% interest each year. So again, we start at 100%. But now we are earning or adding 5% to that. So we need to do 100 plus 5 for a total of 105%. As a decimal, that is equivalent to 1.05. Remember, you move the decimal 2 places to convert any percent to a decimal. So let's write our recursive and our explicit equations in this situation. So the recursive is still going to start out f of n equals f of n minus 1. We're still multiplying. This time it's times 1.05. And again, we're going to start with f of 0, because when we invest money, we always have that 0 start, that very initial amount, because everything happens after we have that initial amount. In this case, that initial is 4,000. For the explicit, I'll use the same process that I did with the prairie dogs. I begin with f of x equals the amount we start with, which is 4,000 in this case, times the common ratio, 1.05, to the power of x, because we're constantly multiplying by 1.05. And here is the end of this video, where we reviewed writing the recursive and the explicit for geometric sequences that involve percentages.